All right. Hi, everyone. Thanks so much for making it to our session. I know it's late in the day, so glad you were able to make it out for one more. The session's called Solving Tough Time-Based Problems with Skeleton Tables and Tableau Prep. I promise there is a reason for all the Bruno Mars. You'll see in a second. My name's Sasha Singh, and this is my co-presenter, Archana Ganeshalingam. We're both senior product consultants at Tableau. You might be wondering how we met, considering I'm from the Austin office and Archana is from the London office. So we actually met at boot camp a couple years ago. When you get started at Tableau, everyone gets shipped off to Seattle, where our headquarters are, for a 2-week training. And we met at the training, became good friends, and since then, to keep in touch, we've been traveling a lot together. If there's one thing we learned, it's that we love to take a good selfie. So we've been to a lot of places: Munich, Portland, Seattle, London, New York. The list goes on and on. We also took a selfie while we were preparing this presentation over WebEx, so we got to shout out Cisco WebEx, without which this presentation would not have been possible. It was a lot of navigating time zones and setting up meeting rooms, so we're really excited to show you what we came up with today. Outside, all jokes aside, we're also really excited to be presenting together because, well, Archana is the local prep expert over in the UK. She presented a session on Tableau Prep earlier today. It was actually live streamed, and then she also presented on Tableau Prep in TC in Europe, so we're in good hands with her.
And likewise, I'm really excited to be presenting here with Sasha. If any of you guys have seen the Superstore demo for Tableau Prep, it's actually Sasha who wrote that demo from scratch, so you're in very capable hands today with her. So with that, onto the agenda. Now, during this session, you're going to become familiar with a mantra: data stored efficiently isn't always stored effectively for analysis. And we're going to come to what that means in just a second. We're going to cover how to recognize situations where you may need to use scaffold tables to pad out your data. And of course, we're going to be showing you how to do this in Tableau Prep. Now, note that all the examples we show you today can be done in Tableau Desktop, but we think Tableau Prep is the right place to do these reshaping challenges because the visual and direct interface makes it easy to spot what exactly is going on with your data. Thank you. So we're going to be doing this by framing our examples from the perspectives of 2 different characters. Now, fitting our transatlantic presenters, we've got a classic British policeman, we've got props, got a budget, big bucks, a classic British policeman, and an American cowgirl. I have to keep my head very steady to balance this. So the database Bobby is a data engineer or a database administrator. They know exactly how the data has been stored and what's in the database. Their main mission is to optimize efficiency in terms of space and query times. This is really hard to balance it on my head. Then we've got our data wrangler. Now, she's an advanced analyst with just one thing on her mind, trying to answer the trickiest of the business's questions. And with some teamwork, they can achieve some really great things, with Tableau Prep being the bridge that will help cross the ocean of analysis that's between them. So with that, I'm going to take this off now. It's hard keeping your head steady. So we've collected 4 different Jedi-level examples from customers that we think exemplify the concepts behind scaffolding. They come from completely different industries, so they don't really relate to each other, but we did that on purpose because the aim of this session is not to take these specific examples away, but more the concepts and the ideas behind what it means to pad and scaffold your data. So don't worry if the examples aren't necessarily relevant to your industry or the fact that they don't really relate to each other. It's more conceptual in nature. That being said, all the workbooks and data sets, as well as the Tableau Prep flows, are going to be made available to you after conference. So we want you to just sit back and let the knowledge wash over you. So don't worry too much about making notes and that kind of thing. So with that, I'm going to hand over to Sasha for our first example.
Cool, thank you. So for our first example, we're going to be looking at data from the Spotify Top 200 charts. And the question that we're asking is, did my track stay in the Top 200 for a long time? So, surprise, the song is by Bruno Mars, and the song that we're looking at today is called 24 Karat Magic. So for anyone who hadn't heard it, up until we played it about 50 times before the session started, it was a worldwide hit. It charted in, I think, over 30 countries, certified platinum in 9 countries, and it won a Grammy. So it was a huge hit worldwide. And the song came out in late 2016. And so, as you would expect, in this visualization, we're looking at just the data from January 1st, 2017 to the data of January 1st, 2018. And so kind of riding that wave of popularity from when it came out, it was still very popular at the beginning of 2017. It was in the top 20 in the Spotify top 200. And then as the year went on, its popularity waned a bit. So what's interesting about the way that the data is being visualized right now is it looks like the song stayed in the chart for the entire time span that we're looking at. When in reality, the song actually fell out of the charts entirely in the fall of 2017. And so in the section that's highlighted on the screen right now or outlined in red, the song fell out of the chart. But what it looks like is that the song stayed in the chart, but maybe just maintained a consistent position. And so ideally what we'd want the data to look like instead is having it be easy to isolate where the song fell out of the chart and when it came back in. So if we take a look at the data and why this is happening, from the database Bobby's perspective, the most efficient way to store this data is just to have a row for every day that the song was in the chart and then a position number if the song charted. So there's nothing necessarily to indicate that the song fell out of the chart or came back into the chart. The way that the data wrangler would want to store the data in the less efficient but more effective way for analysis is to have a date for every single possible day that the song could have charted, and then a position number if the song made it into the chart. So we can see in the outlined nulls indicator that there's 141 days of the year that the song fell out of the chart. And so this isn't necessarily the most efficient way, right? It's going to take up extra space, especially right now we're looking at one song, but imagine if you had all of 200 songs from the chart, we'd have a lot of nulls in our database. But to answer this question, we can scaffold some data. That's where the data wrangler comes in and Tableau Prep comes in. So let me just switch monitors here and let's go through that. All right, so now we're in Tableau Prep, and I'm going to start by just bringing out my Spotify charts data. I always like to add a step in Tableau Prep before I do anything else, just so I can get a feel for what the structure of my data set is. So the first thing I'm going to do here is filter down to the particular song that I'm interested in. So that's going to be 24 Karat Magic. So I'm just going to type that in and then select Keep Only to filter. The next thing I'm going to do is go ahead and bring in my date dim table. So here, if we think back to the data that we just saw in the slide, we're wanting to bring in dates that aren't currently in our data set, right? So in our date dim table, this probably exists in your database back at your organization. This is just a list of dates from the 1st of January 2017 to the 1st of January in 2018. If I join these two together, Tableau is going to do the work for me here in deciding which key to join on. Since we have date fields in both of our data sets, that's pretty easy. And then here I can also decide the join type. And so I'm going to go ahead and make this a right join. The reason I'm doing this, or I'm selecting a right join here, is because I want all of the null values from my scaffold data, right? And then I want to also include the corresponding dates from my original data set. So from there, all I need to do is just add an output. And usually I do like to add in a step after my join too, just so I can make sure that the results of my join all look good. So I'll go ahead and remove my date field, and I'm going to make my new date my default date now. So now if I hop into Prep, or into Desktop, into Tableau, I can start to build out my viz. So I'll go ahead and drag my date field out, and I'm going to look at this at the daily level. And then I'll also go ahead and bring position out. The next thing I'm going to do here is change how I'm formatting my line chart. So I'm going to use a step line here because we are looking at how the song charted and how the rank sort of changed over the year. And so using a step, I think, helps illustrate that very well. I'm going to edit my axis and just go ahead and reverse the scale so that we can see the higher positions in the chart up at the top. And then now we can see that now that we've scaffolded our data and added those nulls, I'm not having those straight lines that Tableau's filling in where there is no data. If so I do have that 141 nulls indicator that we saw on the slide. If I were to go ahead and filter that out, you'll see that that line does fill in, just like we saw on the slide. All right, so let's go over what we just did. In this first use case, it was a simpler one. We wanted to just do it as a warm-up, but I think it illustrates sort of the theme in our session really well. To clearly see when a song fell out of the Spotify Top 200 charts and came back in, we needed to join in a calendar table that gave us a row for every day, in the time period that we're analyzing. So the takeaway here is that when a line item drops out of our data set, there's no record or no null to correct. I know this is a Jedi level session, so some of you Tableau super users might be thinking, why couldn't we use the ZN function, for example, to fix the issue here? But there were no records for those nulls, right? And so we really needed to create that data, and that's where Prep came in and kind of saved the day. You might see this out in the real world. You probably aren't analyzing Spotify data at your organizations, but if you are looking at retail data as an example, maybe you have seasonal retail offerings like Halloween costumes or Christmas trees. You might see a similar use case come up there. And with that, I'll pass it over to Archana for our next example.
So a lot of things in our lives these days are on a subscription basis. Sasha's already mentioned Spotify, but if you think of your Netflix, your Amazon Prime, and even Tableau now. And this data set is going to look at Telecom's contracts. Each row in the data corresponds to a unique contract with what product was sold, when the contract started, how long for, and for how much. Now this data is stored in a way that makes it pretty easy to do some simple analysis, like this. How many of each product did we sell? How many contracts were signed this month? And how long on average do contracts last? But we want to bring out the big guns. When we're looking at contracts data, as a business, it doesn't necessarily matter to us when the contracts were signed. What instead matters is when we're going to get paid, those monthly payments that are due. So what this viz is showing us is how much revenue we're guaranteed each month based on the contracts that we've already signed. So a simple way to explain it is if we stop selling contracts today in October 2018, then revenue would stop coming in towards the end of 2020. So just to go back to the original data structure again, it's going to be a challenge to create this viz. We have a row per contract, but what we really need is multiple rows for each contract, one for each month that a payment is due. So something like this. So contract ID 1, the first one listed, I'll just go back. The first one listed lasts for 11 months with a value of $330. So the structure we want to use for this data is going to be a row for every single month that a payment is due. We're also going to be looking at how we can break down that total contract amount of $330 across the 11 months so we get those $30 increments. So let's go ahead and see how we do that in Prep. Just switch. Number 4. There you go. Cool. So let me go ahead and bring out the contracts table. As Sasha did in her very first step, I'm going to do the same thing and add in a clean step so I can review what my data looks like. So let me go ahead and do that. The next thing I'm going to do is also just check with the profile pane that we do actually have a row per contract ID. So one way you can do that is by switching the view state from a summary to a detailed view. Here we can see that each contract ID has one row associated with it. So now I'm going to go ahead and bring in my scaffold table. For this example, our scaffold table isn't actually a date dim table. We don't need that much detail. It's a lot simpler than that. Let me go ahead and bring it out and walk you through it. Again, I'll add in a clean step to show you what that looks like. Our table is essentially a list of the number of months that a contract could last for. So in our organization, a contract could last for 2 years, so we have 24 rows. from 0 through to 23. We also have a key in our table that we're going to be using to perform a product join between the two tables. So joining every row from our contracts data set to every row in our scaffold table. So the only thing we need to do back in our contracts data set is add in that key. So it's just key with the value of number 1. Now this is a little bit conceptually difficult to follow along, and I think this is where prep becomes super powerful, because all I have to do is drag and drop to perform my join. Tableau Prep, of course, is going to automatically recommend the key that we've created as the join clause, but it's here in the summary of join results where I can actually see what's going on. We see that the 1,000 rows for my contract ID is being joined to all 24 rows in my scaffold table, resulting in a join result of 24,000 rows. That's what we mean by a product join. So let me go ahead and add a clean step. And again, review what that looks like in my profile pane. So now when I hover over each contract ID, we see that we have 24 rows for each one. But if we go back to our explanation, you'll remember that we don't actually need 24 rows. We just need however many rows that contract was meant to last for. So we can start by writing a simple calculation to filter our data down. So we'll filter values so that the number of months is less than the duration that a contract could last for. And I'll hit save. So now when I hover over contract ID 1, we have the 11 rows that we were looking for. Next, we're going to just do a little bit of data cleanup. We don't need our keys in our analysis, so we can go ahead and hide those. And next thing to do is to create our payment date. So our start dates are here, and from there we can bulk out and pad out through the duration of a contract and get our payment dates. So for that, I'm going to put in payment date, and then it's a simple date add calculation. We're adding the number of months to our start date. And I'll hit save. The final thing we have to do is distribute the total contract value across the duration of a contract to get those monthly payments. So that's a really simple one. It's just monthly payment, and it's going to be amount divided by duration. And hit save. Again, we'll add in an output step, and you can run that flow and open it in Tableau Prep desktop and do the same thing. So let me go ahead to my contracts data set and build out the visualization. So rather than bringing out some amount from my measures, we're going to be using some monthly payment. And again, rather than using start date, we're going to be using our payment date. So we'll drag and drop that and select month. We're already starting to see the shape of the final curve we're looking for. The only thing I need to do is add product type onto color and switch it to an area chart. And it's as simple as that. Let's jump back to the slides to recap this example. And hopefully I get this right this time. There we go. So what did we just do? To understand when our customers pay, we need a payment date field. So we need to use a scaffold table to pad out from the start date throughout the duration of a contract. When one record needs to be represented by many marks, we must create additional records. We need to join our data with a scaffold table that has as many records as the maximum number of times that a record will need to be represented. So in our example, this was 24 rows because a contract can last a maximum of 2 years. And you can use these concepts with any subscription-based service where payments might occur weekly, monthly, or annually. And with that, I'll hand over to Sasha to walk us through the next example.
So this next example is going to be around headcounts data. So pretty much every organization is going to have data around who works there, when they were hired, and when they were terminated, if they no longer work there. And this is a really common data problem in our forum, so excited to share this one. So the question we're asking is how many employees are currently on payroll? And it seems pretty simple, right? The way that the data is stored, the more efficient way, is what you would expect. We have a list of employee IDs, and then we have their hire date, and then we have their termination date. If they still work at the organization, then they just have a null for their termination date. So each employee gets one record. So before I even do any scaffolding or padding or anything like that, I want to show you what you can do with the way that the data is stored currently, because this is usually what I do first with my customers. So Okay, so back in Tableau Prep, I got it right this time. I'm going to go ahead and bring out my headcounts table. And I'm going to add a step. And so we see the same data that we saw on the slide there. We've got our employee IDs. And I've got a hire date and a termination date. If I change the way that this is displaying here, I can see that each employee ID gets one row, right? The next thing I'm going to do here is actually pivot my data. And so I'm going to take my hire date, my termination date, and just go ahead and pivot them, and that's going to result in two fields. I've now got a date field, and I have a field called pivot one names that I'm just going to go ahead and rename to event type. I can add in another step, and I'm just going to filter out these null dates. I don't need those. And add an output. And so you can see that now we've got event type, date, and then the employee. So back in desktop, let's see what we can do with this simpler flow. I'm going to start by bringing my date field out, and I'm also going to drag my count distinct of employee IDs out. And so this is just showing me how many employees worked at the organization in any given year. I'm going to go ahead and actually I'm going to take event type and put that on color so we can split this out by our hires and our terminations. And now I'm going to go ahead and add a quick table calculation so we can look at this as a running sum. So we can see over the years how many employees have been terminated, how many have been hired. If I drag a second copy of the count distinctive employee ID out into the view, I'm going to go into the second marks card I have now, and I'll go ahead and duplicate my event type so that I can put that on color instead, that copy. This gives me two legends of the same field, basically, that I can use. And I'm going to go ahead and not exclude, but just hide the hires down here at the bottom. On the top, I'm going to go ahead and edit that table calculation, just add a secondary calculation. So this time it's going to be a difference from, and I'm going to calculate the difference between the two event types relative to the next. And so when I do next, what it's doing there is it's taking the difference between the number of hires in each year and the number of terminations in each year. So now at the bottom we've got just the amount of terminations there were in any given year, and at the top we've got a list of, or a line telling us how many employees were, the difference between the number of employees that were hired and terminated. So now if I dual axis these two lines together and I synchronize my axes, I can start to calculate kind of the next question after just what was our headcount, right? What was our turnover rate? So I can see in 2017, for example, we had 354 people at the end of the year. That was our headcount. And then I can see how many employees were terminated. So that's about a 1:7 ratio. So that's all without any scaffolding or padding. So we are able to answer a couple questions around headcount and turnover without any padding or scaffolding, but let's just say that you guys are a CEO in an organization, right? And at the beginning of the year, you have 1,000 employees working at your company. In the middle of the year, in June, there's a major economic upheaval like Brexit or the Great Recession, and you have to let go of several of your employees. So that would leave you, let's just say you let go of 500 people, and at the end of the year, you were left with 500 employees. By our current definition of headcount, since we were looking at the headcount at the end of the year, that would give us a 100% turnover rate, which isn't really accurate because it isn't taking into account the 1,000 employees that you had working at your organization at the beginning of the year. So a more accurate turnover rate would be looking at the number of terminations. That's data that we already have from our pivot, but that would also be taking into account the number of average daily employees, so we can still account for the 1,000 people that worked at the organization at the beginning of the year. So in order to do that, we will need to scaffold. And so this time, you'll see in this data set, we still have the employee ID, hire date, and termination, but now we have a bar telling us the length of tenure in days, and that's where the scaffold and the dim date table really comes in. So I'll hop back into Tableau Prep here. And I'm going to keep using my headcounts table, just the original data that I had. And I'm also going to bring out a date dim table. This date dim table is a bit longer than my original Spotify one. It goes back all the way to 1963, I believe. In order to join these two together, they don't have a common field, so I'm just going to create a key, similar to what Archana did in the contracts example. So this is just going to be a calculated field in prep, and all it's going to contain is the number 1. So I can go ahead and join both of these tables together. And again, Tableau recognizes that both of those columns are called key and goes ahead and joins on them. I do want to take a second to show you guys what the summary of join results ends up being. So in my final join result, I have over 1 million rows. And if we go back here real quick, in my original headcounts data set, I had only 645. So my data has been duplicated quite a bit. So just to go into what's happening here in a little bit more detail, I'm joining on the key field, right? And that isn't unique. And so I'm duplicating my rows quite a bit. Basically, for every single employee, I am joining in every single date that was in that dim date table, which is very long, going back all the way to the 1960s till present day. So this is good because it does give us the extra dates that we need, but we are also left over with quite a bit extra. What we really need is only the dates for each employee that they actually did work there, right? So let's just say as an example, I worked at Tableau for the past month, since September 23rd of this year. So I would only really need 30 rows associated with my employee ID rather than all of the rows going back all the way to 1963. So I can go ahead and filter these values on a calculation. So just to go over what this calculation is doing here, it's limiting the results of my join down to only the rows that need to be associated with each employee ID based on their tenure in days. And so this first part is just asking if the calendar, so that's our dim date dates, are greater than or equal to the hire date, and if they're less than or equal to the termination date, or if the termination date is null, meaning they still work at the organization. So it's limiting them down. So using myself as an example again, say I'd only worked there for the past month, this would basically cut away all the dates that were relevant to my tenure and leave me with those 30 days. This last part of my calculation, the calendar is less than or equal to today, is leveraging the today function and just limiting the amount of data because my dim date table does extend far into the future. I did that so I wouldn't have to go in and manually input another row every single day. And so this just cuts away those extra days that are at the end. The last thing I'll do in here is just highlight both of these key fields. And I'll go ahead and remove those because I don't need them anymore. They've already done their job. And as a result of the filter we just applied, we're only left with 12,000 rows, so down from over 1 million, so that's great. This will be a lot more performant. And from there, I can just add an output and run my flow. Back in desktop, I got it right this time. I can go ahead and drag out my calendar field here. And once more, I'm going to drag out the count distinct of my employee IDs. Now, if I turn labels on, you'll notice that the number of employees in each year has gone up, and it kind of looks like they're adding up as it goes on, and that's because we're looking at slightly different data now. The numbers that we're seeing, let's just use 2017 as an example. This is how many employees worked at the organization in 2017 as a whole. They didn't all necessarily work there at the same time. Now I just need to write a few calculations with my new data set to find my more accurate turnover rate. And the first thing I'm going to do is find my terminations. So here, I'm going to look at the count distinct, and I'm just going to use a little bit of logic. So I'm going to ask if my calendar equals my termination date, then I want Tableau to return the employee ID. We'll put an N there to wrap that up. And so what this is doing is just returning the count distinct of the number of employee IDs who have termination dates. Now click OK, and I can drag that out And we see that same 51 that we saw earlier with the other flow. The next thing I'm going to do is calculate my average daily headcount. Oh yeah. There we go. So for this, I'm going to be using a level of detail calculation. And I'm going to be using the include LOD. We're including on the calendar field at the level of the sum number of records. So if I zoom back out here, you'll notice in the actual visualization, we're looking at this data at the yearly level, but we do want to look at our headcount at the daily level. And so that's what this LOD allows us to do. It's including looking at the daily calendar dim date table that we just joined in, and then the number of records, right? Each record is going to be associated with the day that an employee worked at the company. And then if I just throw an average around this entire calculation here, that'll give me my actual average headcount. Now I can go ahead and drag that out as well. And I'll go ahead and dual axis these two and synchronize that axis. The last thing we want to do here to find our accurate turnover rate is just divide our terminations by our average daily headcount. And I'll replace that original field with that. Oh, actually, before I do that, I'm going to change the default property so that they format, or this field formats to a decimal or a percentage. There we go. And I'll go ahead and filter as well, just so we can look at the last 10 years of data. That's where we had the most activity. Cool. And then I'm going to go ahead and make this a bar mark type as well. And there you have it. Now we have our more accurate turnover rate because we're looking at this data at the daily level. And so if we were to combine this with just a list of our employees and then when they were hired and terminated, we could start to do some deeper analysis as well. That wouldn't have been possible with our original view. For example, we could look at a specific year, the turnover rate, and see exactly which employees were contributing to that. So if we just go over what we just went through, we scaffolded our headcounts data with the calendar table to understand employee tenure and turnover at a daily level. Similar to the contracts example, the takeaway here is that when one record needs to be represented by many marks, we can scaffold to create those additional records using Tableau Prep. So in this instance, instead of a skeleton table like we used with the contracts, we used a dim date table that allowed us to ask more robust and complex questions because we could look at our data now at the daily level or the monthly level or the quarterly level. You might see this come up out in the real world outside of headcounts if you say work in support or you're looking at data for operations, so something like closed and open tickets. You might also see it if you work in healthcare with admitted and discharged patients. With that, I'll hand it over to Arshana for our last example.
Cool, thank you. So imagine a smart home where every device, light switches, washing machine, TV, absolutely everything is being tracked. The data is being stored by device ID. We've got the start and end time for each state a device could be in, on, off, cycling, etc. The visualization we're aiming for is something where we can see the proportion of time each day that a device spends in a particular state. This is so we can start to spot usage patterns and make changes to live a more energy efficient lifestyle. Now you guys in the audience probably know the drill by now. We're going to need to pad out the data here. But the original data was down to the seconds level of detail. Now most organizations might have a date dim table, but I doubt many of you guys will have one that goes down to the seconds level, a second dim table, if you think of it. So you can easily create one by using the same concepts of scaffolding on a dummy key. Here we just join in an hours, minutes, and seconds table into our data set. These are just numbered from 0 to 23 or 0 to 59, respectively. So that's how we build a seconds level date dim table. So if we imagine that the data wrangler has already gone ahead and done that, and they've join that into our existing data set, again, using a dummy key to join on that one field to create a product join. They might then go ahead and filter out the redundant records, just as we saw Sasha do with her tenure-based example. And we end up with a data set that looks like this. So now the number of records for each row in our for each device and device state is going to correspond to the number of seconds that that device was switched on for. So if we take a look at that first example, it was in the cycling state from the 29th of July through to the 30th of July, from the night into the middle of the day towards lunchtime. So that means it was roughly in that state for about 43,000 seconds. But this data is now stored effectively, but not efficiently, and we're going to see how we can make it more efficient. At this granular level, this takes the data from an original 50,000 or so rows to over 500 million. Let's get a better understanding of why. Take this simple example. The device is going to be switched off between 10:09 p.m. on the 12th of August till the morning of the 15th. But because of the way the data is now structured, this results in a whopping 200,000 records, one for every second that that device was switched off for. What if I told you that just by writing a few simple calculations, we can cut this down from 200,000 to just 4 records? All we have to do is think back to the original question we're trying to answer. We only need data down to the daily level, since that's the visualization we're trying to create. We just have to account for the instances where a device can be in a particular state across multiple days. So in this example, we now have a record from the 12th of August, 10:09 p.m. through to midnight on the same day for that first day. That's what we're calling duration on the start date. Then we have duration in between. These are the whole days in between that the device is in a particular state for. And finally, number 4, we have duration on the end date, which is midnight on the end date through to the time that the device then changes state to the next state. Oh, spoiling the answer there. Let me jump into prep to show you how we can build this out. So go ahead and clear this flow and bring in our smart home devices data set. So I'm going to go in and add in a clean step. And here you guys know the drill. We're going to be adding in a key with just the number 1, which I'll save. I'm then going to go ahead and bring in my date dim table. Again, add in a step. But this time we want to keep it at the daily level. So I'm not going to add in my hours, minutes, or seconds. We'll just keep it as is and then use the calculations to derive our durations from. So here we already have the key. So we'll go ahead and join. And we can see our summary of join results update to show the result of that product join. So it's taken our original 46,000 rows, and after we've done the join, we'll see that our result set is over 1 million rows. So we still have some filtering to do. So let's go ahead and do that. We'll add in a clean step, start by removing our keys, since again, we don't need those for analysis, and remove them. So the first thing we need to do is filter those dates either before or after the device state time zones that we're interested in. So let me go ahead and add that in. So this is just a simple date comparison to compare the calendar dates to the dates in our data set. I'll go ahead and save that. We now see the result set drop from that 1 million rows to just 51,000. So already we've reduced the amount of data we're working with by quite a bit. The next thing we're going to do is build out those duration calculations to calculate the number of seconds that a device is in a particular state. To start, we'll just do a simple date diff calculation, which I'll call duration. This is a date diff calculation, calculating the number of seconds between the start time and the end time. Now we need to distribute this calculation across the multiple days that a device could be in a particular state for. So that's where our 3 different calculations come in: the duration on the start date, the duration in between, and the duration on the end date. So I'll go ahead and add those in. So duration on the start date. There we go. I've done something wrong there. Let's try that again. Hotkeys only work when you remember what the hotkeys are. There you go. So what this calculation is doing is calculating from the start time to midnight on the same day. Remember, we're not going to spend too much time discussing the calculations since this flow, as well as the workbooks and stuff, is going to be made available to you after conference. But that's what it's doing behind the scenes. Then we've got our next calculation, which is the duration in between. This is for the whole days, so 24-hour periods that a device is in a particular state for in between that start and end date. So this is our day duration. Here the calculation is a little bit more simple, since we always just add a consistent value of 86,400, the number of seconds in a day. Next, we add in our duration on the end date. Similar to the start date, this is just midnight on the end date through to the end timestamp. So once you've got that in, we can save those, and then we need to combine the three calculations together in a field I'll call total duration. So this is adding our duration on the start date with the duration in between with the duration on the end date, or three. Now that we've got all the data we need, let's jump into Tableau Desktop to see how we can visualize that. So here, I'm going to go ahead and pause the query. So I know this is a Jedi level session, but if some of you guys don't know, I only learned about this relatively recently, is the ability to pause a visualization as you build it, so that you can build it out and then hit play and one query is sent and it's all very quick and fast. So I'll hit pause and build this out. So now what we need is the total duration on columns. We're going to bring out device state onto color to break that down so that we get the stacked bars we're looking for. We need our device ID on rows so we can see and compare each device. And we're going to look at this at a daily level. So we need our date field from our calendar table at a daily level. Last thing I'm going to do is I wanted to look at the proportion of time, not the absolute values. So I'm just going to use a quick table calculation for percent of total that's computed across device state. So here is where you see the magic happen, because I can just go ahead and hit play, and bam, we've got our viz. I just need to switch this into a bar chart, and there we see the stacked bars adding up to 100% each time. So now we can start to spot patterns within our data. So let me jump back to the slides and recap what we just covered. So the viz in our example only needed the daily level of detail. So we can use simpler scaffolding with just a few filters and calculations to derive the data at a lower level of detail. To take these concepts and apply them to your own data sets and examples, just know that when scaffolding results or could result in a data explosion, just go back to the original question you were trying to answer and ask yourself, do you really need that granularity? This specific example, however, you can apply across many different industries. Think about manufacturing, if you're working and looking at production line effectiveness with machine on-off times. If you're looking at facilities management with device, seat, or space utilization. And also if you're looking at employee time cards, people might punch in every day and during breaks in and out, but you might need to calculate their weekly or monthly wages. So there your granular data is at the hourly level, let's say, but the viz only needs to be at a weekly or a monthly level. So with that, let's wrap up with Sasha.
So with mantras, we hear the trick is you do have to say them over and over in order to remember them. So I'm going to say it one more time. Data stored efficiently is not data stored effectively for analysis. So in our examples, that was usually the case. The database Bobby was storing data in the most effective way, and the data wrangler came in and with prep was able to scaffold and pad data out to have it be more effective for analysis. Padding our data with the scaffold, skeleton, and calendar tables allows us to bridge the gap between efficiency and efficacy. Paired with Tableau Prep's visual and direct interface, we can operationalize these processes, especially with the announcement of Prep Conductor today. That was very exciting for us as well. This makes solving these time-based problems and performing this analysis much easier. And with that, that brings us to the end of our content. If you enjoyed our session so much that you want to come back for some reason, or if you want to send one of your colleagues our way, we are going to be repeating it on Thursday from 2:15 to 3:15. Here are a couple of other sessions on prep that we thought were interesting. You don't have to write these down or anything, but if you type in prep on the app, all of the prep sessions will come up. These sounded really cool to us. And of course, please complete the session survey in the My Evaluations menu from your TC18 app. We'd love if you rated us 5 stars. If you didn't like the session, go ahead and rate us 5 stars anyway, and just let us know what we can do better next time. And with that, thank you for coming. If you guys have any questions, we'll be hanging out at the end.